Good morning. Today's topic interconversions of monosaccharides, that is glucose to fructose, glucose to mannose, glucose to arabinose, arabinose to glucose, arabinose to fructose, arabinose to mannose. Here in the interconversions, before that the Haworth structures of fructose. Here fructose form two isomeric pyranose, that is fructoses, fructosicides, that is alpha defructopyranose, beta defructopyranose. Here pyranose means six-membered ring. Here the alpha defructopyranose and beta defructopyranose are anomers. Anomers means the compounds having same formula but differ in the arrangement of atoms on the second carbon is called anomers. And the second carbon is called, that is the functional group carbon is called, that is anomers. Alpha carbon is epimers. Here in the Haworth representation, that is alpha defructopyranose, that is CH2OH, COH, CHOH, 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 CH2. Means in the fructose, the second carbon and sixth carbon linked to oxygen atom. Here in the alpha defructopyranose, the second and third carbons OH groups are trans to each other. Similarly, in the beta defructopyranose, same, that is in the pyranose ring, second and sixth carbons are linked through oxygen atom, in which the second carbon and third carbon OH groups are seamed to each other. It is beta defructopyranose. These two are called anomers. Next one, alpha defructopyranose. Pyranose is a five-membered ring. In the pyranose structure, the second and fifth carbons are linked through oxygen atoms. The pyranose, second and sixth carbons are linked through oxygen atom. But in the pyranose structure, the second and fifth carbons are linked through oxygen atom. The fructopyranose structure is CH2OH, COH, CHOH, CHOH, CH, CH2OH. This fifth carbon is linked to the oxygen with the second carbon. In the alpha defructopyranose, the second and third carbons OH groups are trans to each other. In the beta defructopyranose, same, the second and third carbons OH groups are syn to each other, cis to each other. It is CH2OH, not H. It is CH2OH, COH, CHOH, CHOH, CH, CH2OH. This fifth carbon and second carbon is linked to the oxygen atom. Here, these alpha defructopyranose and beta defructopyranose are anomers. In the interconversions of monosaccharides, first conversion of aldopentose to aldohexose. Aldopentose means arabinose, that is conversion of arabinose to either D-glucose or D-mannose, means conversion of lower aldoses to next higher aldoses, that is through Killiani-Fischer synthesis. It is the increasing the carbon atom of aldopentose to aldohexose through Killiani-Fischer synthesis. Means in the Killiani-Fischer synthesis, an aldose can be converted to next higher aldose by this method. That is conversion of D-arabinose to D-glucose and D-mannose. Here in the conversion of D-arabinose to D-glucose, the method involves the following steps. 4 steps are involved in the conversion of D-arabinose to D-glucose or D-mannose. First step is the given aldose, that is arabinose or aldopentose, upon treatment with hydrogen cyanide undergo nucleophilic addition to give cyanohydrine. That is the cyanohydrine, or that is the 2-diastereoaromatic cyanohydrines, or it can also called gluconitrile or mannonitrile. Which in the second step, the 2-diastereoaromatic cyanohydrines on hydrolysis to form, that is carboxylic acids, which can be separated. Carboxylic acids are that may be either gluconic acid or mannanoic acid. Third step, the 2 carboxylic acids on heating, it can loses water molecule to form stable gamma lactones. In the fourth step, the lactones are reduction in the presence of sodium amalgam. It gives higher aldoses like glucose and mannose. Here in this process, first arabinose to glucose. First arabinose, that is D-arabinose upon treatment with hydrogen cyanide. Here arabinose is a 5 carbons containing aldopentose, that is CHO, CHOH, 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 CH2OH. It is D-arabinose. Upon treatment with hydrogen cyanide, first it gives rise to gluconitrile. It is a cyanohydrine product. Cyanohydrine addition product. The obtained product name is gluconitrile. Is CN, CHOH, 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 CH2OH, which undergo hydrolysis. That is the second step. The diastereoaromatic cyanohydrines undergo hydrolysis to give, that is the 2 carboxylic acids which can be separated, that is gluconic acid is obtained. Gluconic acid is COOH, CHOH, COHH, CHOH, CHOH, CH2OH. This gluconic acid, upon heating, it undergo dehydration to give more stable gamma lactone, that is CO, CHOH, COHH, CH, then this gamma carbon, or that is the 4th carbon, is linked to the first carbonyl carbon with the oxygen atom. Then CHOH, CH2OH, it is called gamma lactone. This gamma lactone undergo reduction in the presence of sodium amalgam. It gives glucose, D-glucose, that is CHO, CHOH, 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 CH2OH. It is called D-glucose or aldohexose. Next one, conversion of arabinose to mannose. Again, arabinose is a 5-membered aldopentose, CHO, CHOH, 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 CH2OH. Upon treatment with hydrogen cyanide, first it gives the diastereoaromatic cyanohydrine of mannonitrile, CN, CHOH, 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 CH2OH. This mannonitrile undergo hydrolysis in the presence of acid media it gives mannanoic acid or mannoic acid is COOH, CHOH, 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 CH2OH. It is called mannoic acid. Upon heating, again undergo just a dehydration with a gamma carbon, then it gives stable gamma lactone is CO, CHOH, CHOH, CH, then the gamma carbon or fourth carbon is linked to the first carbonyl carbon, then CHOH, CH2OH, it is called gamma mannolactone, which undergo reduction in the presence of sodium amalgam in water, it gives D-mannose. It is called Ileani-Fischer synthesis, in which the aldopentose is converted to aldohexose, that is glucose or mannose. Next, Lebroy-de Bruyn-Van Akenstein rearrangement. It is also called LDV rearrangement. L means Lebroy, D means De Bruyn, V means Van Akenstein rearrangement. Here in this rearrangement, fructose, though a ketone, gives Tollens test, time failings test. The reason for this anomaly explained by Lebroy-de Bruyn-Van Akenstein rearrangement. In this rearrangement, that is fructose or glucose or mannose on heating with alkali can be converted into the mixture of glucose, fructose and mannose. The same mixture can be obtained from either glucose or mannose also. Here, the formation of mixture of glucose, fructose and mannose from any one of them in presence of alkali can be explained by the formation of enediol as intermediate product. That is, enediol is a intermediate product. First here, it is D-glucose, CHO, CHOH, CHOH taken 3, CH2OH, it is called D-glucose. Upon treatment with dilute alkali, undergo ketoenol tautomerism to form enediol is CHOH, double bond COH, CHOH taken 3, CH2OH. It is called enediol. The same enediol is also obtained from D-fructose is CH2OH, C double bond O, CHOH taken 3, CH2OH. It is D-fructose. Upon treatment with dilute alkali, again it undergo tautomerism, ketoenol tautomerism to give enediol. The same enediol is also obtained from D-mannose upon treatment with dilute alkali, that is CHO, CHOH, CHOH taken 3, CH2OH upon treatment with dilute alkali to form enediol. Means due to the presence of the enediol as intermediate product, then the fructose, though a ketone, even though it is a ketone, it gives the Tollens and failings test. The reason for this anomaly can be explained by the Lebroy-de Bruyn-Van Akenstein rearrangement. In the Lebroy-de Bruyn-Van Akenstein rearrangement, the either glucose or fructose or mannose upon treatment with the dilute alkali, it gives the mixture of glucose, fructose and mannose. The formation of mixture of the same mixture can be obtained from either glucose or fructose or mannose. The formation of mixture of glucose, fructose and mannose from any one of them in presence of alkali can be explained by the formation of enediol as an intermediate product. From this intermediate, then the D-glucose converted into D-fructose, Similarly, D-glucose converted into D-mannose. Similarly, the D-mannose converted into D-glucose. The same reaction can be explained in shorthand notation is CHO, HOR. That is, example, it is glucose upon treatment with alkali, it undergo tautomerism. Ketoenol tautomerism to give CHOH, C double bond C, or OH is enediol. The same thing can be obtained from mannose. The same thing can be obtained from fructose. This rearrangement is called Le Broglie Van Akensten rearrangement. Next, conversion of aldohexose to aldopentose means it is the Ruff's degradation. Means in this method, aldohexose, that is glucose, is converted into aldopentose, that is arabinose. Means decreasing the carbon atom, or preparation of aldohexose to lower carbon containing aldopentose, that is aldohexose to aldopentose. This method involves the following steps. Following 4 steps. Again, it is also same. First step is aldohexose undergo oxidation with mild oxidizing agent like bromine water. It gives, that is gluconic acid or aldohexanoic acid or aldoic acid. In the second step, this gluconic acid or aldohexanoic acid upon treatment with lime water, it gives a calcium gluconate. Calcium gluconate, or it can also call calcium aldonate. This calcium gluconate or calcium aldonate upon treatment with Fenton's reagent. Here Fenton's reagent is the mixture of ferrous sulfate and hydrogen peroxide. Here this calcium gluconate upon treatment with Fenton's reagent, that is FeSO4 H2O2, it gives the keto acid, alpha keto carboxylic acid, that is called aldoic, that is alpha keto acid, which upon heating, in the fourth step, this keto acids upon heating loses carbon dioxide to form arabinose or aldopentose. That is, it is called Ruff's degradation. Ruff's degradation involves 4-step reaction. First step is aldohexose or glucose undergo oxidation with bromine water to give gluconic acid is first step. Second step, gluconic acid upon treatment with lime water, it gives calcium gluconate. Third step, calcium gluconate upon treatment with Fenton's reagent, FeSO4 H2O2, it gives keto acid. Fourth step, keto acid upon heating, removal of carbon dioxide to give aldopentose. It is called Ruff's degradation. In the equation, that is aldohexose, CHOH taken for CH2OH, it is called glucose or aldohexose. Oxidation with bromine water, it gives aldonic acid or gluconic acid is COOH, CHOH taken for CH2OH. This gluconic acid treatment with lime water, it gives calcium gluconate, that is COO minus CHOH taken for CH2OH taken to Ca plus 2. This calcium aldonate or calcium gluconate upon treatment with Fenton's reagent, is FeSO4H2O2 or Fe plus 2 H2O2. Then it gives keto acid is COOH, CO, CHOH taken 3, CH2OH. It is called keto acid. Upon heating, then removal of carbon dioxide to give aldopentose, that is arabinose, CHO, CHOH taken 3, CH2OH. It is called aldopentose. Similarly, the D-mannose can also be converted into D-arabinose by Ruff's degradation. Next, conversion of aldohexoses to ketohexoses. That is, aldohexose is glucose, ketohexose is fructose. Means conversion of glucose to fructose. Here it involves three-step reaction. Conversion of glucose into fructose with the following three-step reaction. First step is glucose on reaction with phenylhydrazine. Excess of phenylhydrazine hydrochloride to give osazone of glucose. This osazone on acid hydrolysis to give ozone. Ozone on partial reduction with zinc acetic acid to give fructose. Once again, conversion of glucose to fructose takes place following three-step reaction. First step is glucose upon treatment with excess of phenylhydrazine hydrochloride to give osazone, that is glucosazone. Second step is glucosazone on acid hydrolysis to give ozone. Third step, ozone on partial reduction with zinc in acetic acid to form, that is fructose. Here in this reaction, first glucose, D-glucose is CHO, CHOH, COHH, CHOH, CHOH, CH2OH. It is called D-glucose. This D-glucose upon treatment with excess of phenylhydrazine hydrochloride, it gives a solid yellow crystalline derivative of osazone of glucose. It can also call glucosazone is CH double bond N NH C6H5, C double bond N NH C6H5, CHOH, 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 CH2OH. It is called glucosazone or osazone of glucose. This osazone on acid hydrolysis means a osazone on acid hydrolysis. It gives ozone. This ozone containing two functional groups, aldehyde as well as ketonic group, that is CHO, C double bond O, that is CHOH, 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 CH2OH. It is called ozone of glucose. Glucosone, glucosone. This in the ozone, this ozone undergo partial reduction with zinc in acetic acid. Here among the aldehydes and ketones, aldehydes are more reactive than ketones. Therefore, aldehydes undergo reduction to give primary alcohol, that is CH2OH, C double bond O, CHOH, 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 CH2OH. It is called D-fructose. Means conversion of D-glucose to D-fructose. Means aldohexose to ketohexose takes place from following three-step reaction. First step, glucose upon treatment with excess of phenyl hydrochloride to give yellow solid crystalline derivative of osazone. Glucosazone is this glucosazone on acid hydrolysis to give ozone or glucosone. This glucosone undergo partial reduction with the zinc acetic acid. It gives D-fructose. That is the conversion of aldohexose to ketohexose. That is glucose to fructose conversion. Next, conversion of ketohexose to aldohexose. Reverse process means conversion of fructose to glucose. The fructose can be converted into glucose with the following, again, same four-step reactions. Four-step reaction. First step is fructose undergo reduction with nickel, platinum or palladium. It gives the mixture of, that is the epimeric mixture of sorbitol and mannitol. Epimeric mixture of sorbitol and mannitol. In the second step, this sorbitol and mannitol on oxidation with nitric acid. On oxidation with the nitric acid to give respective gamma lactones. Respective gamma, the concentrated nitric acid to give, that is gluconic acid. In the third step, this gluconic acid or mannoic acid can be separated and heated to give, it undergo dehydration to give their respective gamma lactones. This gamma lactone again undergo reduction with the zinc acetic acid. It gives aldohexose, is called glucose. Here the conversion of fructose to glucose takes place following four-step reaction. First step is fructose undergo reduction with nickel, platinum or palladium to give epimeric mixture of sorbitol and mannitol. In the second step, this sorbitol or mannitol undergo oxidation with concentrated nitric acid to give, that is gluconic acid or mannoic acid. In the third step, this gluconic acid or mannoic acid upon heating loses water molecule to form their corresponding gamma lactones. In the fourth step, this gamma lactone undergo reduction with zinc acetic acid. It gives glucose, that is aldohexose. In the conversion of fructose to glucose, the chemical reactions involved is, the first step, first fructose is CH2OH, C double bond O, CHOH taken 3, CH2OH. It is called fructose. This fructose undergo reduction with nickel or platinum or palladium. It gives the epimeric mixture of, that is sorbitol and mannitol. It is called excitols, is CH2OH, CHOH, CHOH taken 3, CH2OH. Here in the sorbitol, the second carbon H present left side, OH right side. In the mannitol, second carbon HO present in the left side, H present in the right side. Therefore, it is epimeric mixture. Sorbitol and mannitol are called epimeric mixture, which undergo oxidation. with concentrated nitric acid, the first carbon containing primary alcoholic group undergo oxidation to give acid group, that is aldonic acid or gluconic acid or mannoic acid, COOH, CHOH, CHOH taken 3, CH2OH. It is called hexanoic acid, aldohexanoic acid, or it can also call gluconic acid or mannoic acid. This gluconic acid or mannoic acid upon heating with the removal of water at fourth carbon, that is the gamma carbon, to give gamma lactones, that is gluconolactone or mannanolactone. Structure is CO, CHOH, CHOH, CH, that is fourth carbon linked with the first carbon, carbonyl carbon of through oxygen atom, CHOH, CH2OH, it is called gamma lactone. This gamma lactone undergo reduction with zinc acetic acid to give, that is aldohexose, is called glucose. CHO, that is CHO, CHOH, 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 CH2OH. It is called aldose. It may be either glucose or mannose. If it is glucose, the second carbon H present in the left side, OH right side. If it is mannose, in the second carbon, OH present on the left side, H present on the right side. Therefore, this glucose and mannose are also a epimeric mixture or isomers of epimers. Next, conversion of fructose to mannose. Fructose to mannose. Same 4-step reaction. First, fructose undergo reduction with nickel, platinum or palladium to give mannitol. That is CH2OH, CO, CHOH taken 3, CH2OH. Undergo reduction with sodium amalgam or nickel, platinum or palladium. It gives the mannitol. Mannitol is CH2OH, COHH, COHH, CHOH, CHOH, CH2OH. It is called mannitol. This mannitol undergo oxidation with nitric acid to give mannanoic acid, or mannoic acid is COOH, COHH, COHH, CHOH, CHOH, CH2OH. It is called mannoic acid. This mannoic acid upon heating, just a removal of water, to give gamma lactone, C double bond O, CHOH, COHH, CH. This fourth carbon is linked to the first carbonyl carbon through oxygen atom. Then CHOH, CH2OH, it is called gamma lactone, undergo reduction with the sodium amalgam or zinc acetic acid to give, that is D-mannose. D-mannose formula structure is CHO, COHH, COHH, CHOH, CHOH, CH2OH. It is D-mannose. In the D-mannose, the second carbon differ in the arrangement of atoms on the second carbon. Here, that is in the second carbon, that is the OH group is present in the left side, hydrogen is present on the right side, is mannose. But in the glucose, the second carbon H present in the left side, OH present in the right side. That is called D-glucose. Next, conversion of glucose to arabinose. In the previously we discussed Ruff's degradation method. Previously we discussed Ruff's degradation, that is higher aldoses to conversion into lower aldoses. Ruff's degradation. The same thing, conversion of glucose to arabinose by the Holt's method. It is the another method. Cole's method. This method involves the following 4 steps. Again, this method involves the following 4 steps. First step is glucose. Upon treatment with hydroxylamine, it gives oximes of glucose. Glucose oxime is the first step. In the second step, this oxime of glucose, upon treatment with acetic anhydride, it gives the pentaacetyl derivative of D-gluconitrile. Pentaacetyl derivative of D-gluconitrile. In the third step, this pentaacetyl derivative of D-gluconitrile, upon treatment with Tollens reagent, that is silver oxide, here it gives the, that is cyanohydrines of, that is the cyanohydrines of pentoses. Here this cyanohydrines of pentoses are cyanohydrine, the alkyl nitriles of hexoses. This cyanides or cyano derivative undergo elimination of hydrogen cyanide in the fourth step. It gives D-arabinose. By this 4-step reaction, we can convert D-glucose to D-arabinose. This method is called Cole's method. Once again, here in the Cole's method, conversion of D-glucose to D-arabinose takes place from following 4-step reaction. First step, glucose upon treatment with hydroxylamine to give oxime of glucose. In the second step, this oxime of glucose upon treatment with acetic anhydride to give pentaacetyl derivative of D-gluconitrile. This pentaacetyl derivative of D-gluconitrile upon treatment with Tollens reagent, silver hydroxide, it gives the cyano derivative of D-gluconitriles. This cyano derivative of D-gluconitriles undergo elimination of hydrogen cyanide to give arabinose or D-pentose. Here in the reaction mechanism or in the reaction of conversion of D-glucose to D-arabinose through Cole's method. First here D-glucose is CHO, CHOH, COHH, CHOH, CHOH, CH2OH. It is D-glucose. Upon treatment with hydroxylamine, just here removal of water. Generally, aldehydes upon treatment with hydroxylamine, it gives aldoximes. Similarly, it gives D-glucose oxime or oxime of glucose is, that is CH double bond NOH, CHOH, CHONH, CHOH, CHOH, CH2OH. This oxime of glucose upon treatment with acetic anhydride, it gives the pentaacetyl derivative of D-gluconitrile is CN, CHOCOCH3, COCOCH3, H, CHOCOCH3, CHOCOCH3, CH2OCOCH3. It is called D-gluconitrile of pentaacetate, which upon treatment with Tollens reagent of silver hydroxide, Here the silver hydroxide, the acetyl derivatives undergo hydrolysis to give hydroxy compounds, that is D-gluconitrile, that is CN, CHOH, COHH, CHOH, CHOH, CH2OH. It is called D-gluconitrile. Upon heating, with the removal of hydrogen cyanide, to give D-arabinose, or it can also call aldopentose, is CHO, COHH, CHOH, CHOH, CH2OH. It is called arabinose or aldopentose. It is the conversion of aldohexose to aldopentose by Cole's method. Means glucose to arabinose conversion. With this, carbohydrates is completed. Thank you.